Hi guys, we're going to talk about pressure concept. This is in Unit 3, Section 2. You'll need your notes, which is pen and paper, and a calculator, so don't forget to make sure you get your calculator. So we're going to talk about what pressure is, their units, their unit equivalencies. We're finally going to talk about what STP is, and then unit conversions. So pressure, it's a force applied over a specific area, and you'll see this a lot in physics. Here, specifically in Unit 3, we talk about gases, so this is gas pressure. This is when gas molecules strike the sides of the containers, meaning that when they hit the containers, the particles themselves are bombarding with the edges of the container, or with other particles. Atmospheric pressure is all the pressure around us. So it's all of those air particles or molecules that are hitting you. That's actually adding to air pressure, or atmospheric pressure, excuse me. We measure pressure with a barometer, a manometer, or different sensors. So we have so many units of pressure. There's a lot of these. We have ATMs, that stands for atmospheres. PA stands for pascals, and notice that's a capital P. N over M squared is newtons per meter squared. You'll probably use that in physics a lot. kPa is kilopascals. BARR is bars, and TORR is torrs. It stands for Torricelli, an Italian scientist who discovered it or named it. mmHg is millimeters, that's what the mm is, and the Hg is the chemical symbol for mercury. INHg is just inches of mercury. And then we have Lb over inches squared, or IN squared, and that stands for pounds per square inch, or PSI. If you've ever had to inflate tires, you generally look at PSIs. So here in chemistry, we will definitely talk about atmospheres, kilopascals, you'll see torrs, mmHg, and then PSIs. In physics, that will most likely be N per meter squared, or newtons per meter squared, and a few of these other ones as well. So let's look at the equivalencies and kind of what this all means. So just kind of give you an example, on the right-hand side, we have a picture of the Earth, or at least part of the atmosphere. Notice that at sea level, so where we are right here, it's about 1.00, and the unit is an ATM, or atmospheres. As we increase the altitude gets higher. The pressure actually ends up decreasing, so we have less pressure as we get higher up in the atmosphere. So if we look over here, Mount Denali in Alaska is half the amount of pressure than we have here at sea level. Take a look at the temperature too. I definitely would not be a fan of that. And if we look at an airplane, 35,000 feet, it's a quarter of the pressure of what we have here at sea level. We'll also look at these boxes. So notice here that in a certain volume, you have a lot more particles than you do as you increase in altitude. So let's go through the equivalency. So at sea level, that's 1 ATM. That's equal to 101,325 PA, or pascals. That's the same thing for newtons per meter squared. So actually pascals and newtons per meter squared are the same. It's equal to 101.325 kilopascals, and that makes sense because Pascal is going to be 1,000 of whatever kilopascals is, so we actually move the decimal place over 3 spots. It's equal to 760 torr, which is the same as millimeters of mercury. So torr and millimeters of mercury are the same. It's equal to 29.92 inches of mercury, and then 14.7 psi. So all of these pressure amounts are here at sea level of where we are right now. All right. Don't forget that these two are the same, and these two are the, oops, just kidding, not those two. These two are the same. All right. And they're all equal to 1 ATM. So let's talk about when we go under the water, under sea level. On the right-hand side, that's my husband Paul. He has now gotten into scuba diving, so I know a lot more about this. So as he goes down the depth, the pressure will actually increase. So there he is going down. He's currently at sea level, then he goes down to 33 feet, 66 feet, and then he hasn't been down to 99 feet, but that's really a high amount of pressure. So we'll go through. At 0 feet, it's 1 ATM, that's at sea level. This is where our volume is, and then the density. So notice what happens to a balloon. So if we took a balloon down underwater, what happens to the volume? So as we increase in the depth, meaning we go down further, that volume will also increase. Take a look at the density. So how many of these particles are going to be in this balloon, or excuse me, how tightly packed these particles are. There's still going to be the same amount of molecules or same amount of dots in each of these 4 balloons here, but the concentration gets higher, meaning that the amount of molecules per area is increasing. So as we go down, and this is a general rule, this is what scuba divers need to know, as they go down 33 feet, which is 10 meters, the pressure doubles. If they go down to 66 feet, the pressure will triple, that volume will be cut by a third, and the density will be tripled. If we go down to 30 meters, 99 feet, the pressure is quadrupled, the density is also quadrupled, but the volume is cut into a quarter. Okay, so now we can kind of see what happens with pressure, volume, and density as well. These are not numbers you ever need to memorize. I just want to make sure that you see them, just so you have an idea of what happens with scuba divers. So when we have, we'll talk about STP here. So up until this point, if you've ever seen a multiple choice question or a free response and it says the letters STP, I've told you to ignore it until Unit 3. Well, we're in Unit 3 now, so now we have to make sure we pay attention to it. And this is found in Table A. This is the first table on your reference table, so you don't have to look far in order to get to it. The S stands for standard, so pretty much standard conditions, normal conditions. So in some old multiple choice questions, you might see it as normal conditions or standard conditions. We have T, which stands for temperature, and the P, which is pressure. So let's take a look at pressure. Standard pressure is 101.3 kilopascals, which is equal to 1 atm. So this is at sea level. Standard temperature is 273 Kelvin, or 0 degrees Celsius. And again, you never need to memorize these numbers, you just need to know that they're on Table A. Always, always, always now pay attention to if it says standard or STP or normal, because then that means that you have to go to these values. So let's go to unit conversions. We know that 1 atm is equal to all of these values. Make sure that these numbers do get down. I will give you these values except for, let's see, atm and millimeters of mercury, because they're actually on Table A for you. Let's see. I'm sorry, kilopascals. I will give you everything except for kilopascals and atm, because again, they're on Table A for you. So everything else should get written down. Let's go through a problem. We want to convert 699 millimeters of mercury into atm, or atmospheres. So we're going to do something called dimensional analysis. This is actually one of the most easiest math things I think of, because you're just canceling units. You just need to know that all of these equivalencies at the top, you can put them into fractions. So 1 atm, let's see, is equal to 760 millimeters of mercury. So this is something called a conversion unit. I can flip this the other way. It could be 760 millimeters of mercury over 1 atm, and it still means the same thing. So I'm going to start with the number that they give me. 699.0, don't forget that 0, because that means that we need to have sig figs at some point, millimeters of mercury. I'm going to be setting up a whole bunch of fractions, so I can put this over 1 just to make this more comfortable for you guys. But I want to make sure I get out of millimeters of mercury and I get into atms. So I have to figure out what my conversion unit would be in order to do that. So I actually have this one right up here for you. I did atm and millimeters of mercury, whatever those conversion factors were from the equivalencies, and I can put it into a fraction. Now, remember, I can flip this fraction upside down too. I need to know what I want to put on the bottom versus the top. Always remember, whatever unit you want goes on top. Whatever unit you're trying to get rid of goes on the bottom. So I have millimeters of mercury right here. I'm going to put that down at the bottom because I want to get rid of it. I don't want it anymore. And from there I can put in ATM. Use the numbers here to fill in what you need. Okay, so I have 1 ATM and 760 millimeters of mercury. Now I can go through and cancel out units. This is the best part. Get rid of units. I can get rid of millimeters of mercury because it's on the numerator and the denominator. It cancels out. The only unit left is ATM, which is the unit that I want. So I can plug this into my calculator. It ends up being 699.0 divided by 760. I don't need to multiply by that 1 because it's just 1. It's fine. Alright, so I have a number in my calculator, 0.91973, etc. Many of you guys say that this is a big number in your calculator. This isn't a big number. It's just, it has a lot of digits. You have to make sure that you round it to proper sig figs. So let's go through the sig figs. The first number we have is 6990. We have a decimal point, so that 0 behind it counts, or the lagging 0 counts. So this has 4 sig figs. Don't worry about the units or the sig figs for ATM. That's just there. And then you have 760. There is a decimal point. So, there is a decimal point that I just got rid of. That means that this has 3 sig figs. Whenever we're multiplying or dividing, use the least number of sig figs in your answer, so that's 3. This leading 0 doesn't count because it's just a placeholder. It's a number in front of a decimal point. So I have 1, 2, 3. I'm going to cut it off there. I have 3 sig figs there. Then I'm going to look at my next number to see if it'll round these up, and it does. So 0.919 actually ends up rounding to 0.920. So I know that my leading zeros never count. My lagging zeros only count if there's a decimal point, and in this case, it does count. So I have 1, 2, 3 sig figs at the end. Don't forget your units, ATM, and put a box around your answer. So you'll get credit for setting up this equation properly, making sure that you have the proper answer at the end, the correct number of sig figs, units, and a box. The biggest thing also is don't forget to put that 0 in the front. If you don't have that 0, you're getting it wrong, so don't lose a silly point for that. That 0 has to be there, okay, especially with that little decimal point. Alright, let's move on. Example number 2, convert 350-point torr into kPa. So let's figure out which ones I need. I have torr, so I know I'm going to need torr up here. I'm going to highlight that. And I want kPa at the end, so I'm going to highlight that as well. So I'm going to start out with the number that they give us, 350 torr. Making sure I have that decimal point there so that I can remember sig figs at the end. Put it over 1 to make it more comfortable for yourself. And now you have to figure out what unit goes on the top versus the bottom. Whatever unit you're trying to get rid of, that goes onto the bottom. So I know I'm trying to get rid of torr, so I'm going to put that on the bottom. I want kPa, so that unit goes on top. Then use these numbers to fill in for you. So kPa is 101.325, and then the torr is 760. Alright, so when you put this into your calculator, it's 350 times 101.325. Press the equal sign. Then divide that number by 760 torr. All the stuff in my calculator is 46.6628. So now I have to check on sig figs. Let's see. This has 3 sig figs. This has 6 sig figs. And then this has 3. So when I'm multiplying or dividing, I want to use the least number of sig figs in my original ones. So that ends up being 3. So I'm going to go over 1, 2, 3, put a line next to that. And check to see what this number does. This number is above a 5, so it's going to round up that number. So this ends up being 46.7. Use that units, kPa. And that's your final answer. Don't forget, the reason we did this is to cancel out torr, so get rid of them. It's easier enough. Okay. Keep going. And sorry for that little blip. Alright. Okay. So, example 3, convert 0.984 ATM into torr. So, let's check the equivalencies. I have ATM. I'm going to highlight that. And I want torr at the end. So, I'm going to highlight that. That's going to be my conversion factor. So I have, let's see, 0.984 ATM. I'm going to use that because that's the number that they give me. You could put it over 1 to make it more comfortable for yourself. And now I have ATM and Tor. I need to figure out what goes on the top versus the bottom. I'm trying to get rid of ATM up here, so I'm going to put ATM at the bottom over here, and then Tor on top. Fill in the numbers from the equivalencies. Okay, cancel out units. And then plug this into your calculator. This ends up being 0.984 times 760 divided by 1, but anything divided by 1 is itself, so don't worry about that. And from here, we end up getting 747.84, and we need to figure out how many sig figs we have. So over here, I had 3 sig figs. This is 3 sig figs, so I'm going to go over 1, 2, 3. Put a line right there. This 8 ends up rounding up that 7, so it's 748 Tor. And then the last little example that we'll do here together is figuring out if we have 75.0 kPa into millimeters of mercury. So I have kPa here, I have millimeters of mercury there. I'm going to use the number that they give us first, 75.0 kPa over 1. And I want to get to millimeters of mercury, so that's the unit I want. I know I can have an equivalency for it, so it's millimeters of mercury over kPa. And let's put in the numbers from the equivalencies, 101.325 kPa, and then 760, don't forget the dot, for millimeters of mercury. Alright, let's cancel out kPa. We are left with millimeters of mercury at the end. We have 562.546, etc. Okay, and the way I got this was 75 times 760. Press enter into your calculator, or equals into your calculator, and then divide it by 101.325. So here I have 3 sig figs, 3, this has 6, so we're going to use 3 sig figs in our final answer, so I have 1, 2, 3. And then that 5 makes that 2 go up, so it's 563, and the unit was millimeters of mercury. Right. Okay, so for summary, pressure is force per area. If we have something called standard conditions or normal conditions, go back to Table A, and don't forget how to do those unit conversions. I will give those equivalencies to you, except for kPa and ATM. But everything else I will be able to give to you. Don't memorize them. That's not the point of it. Okay? Also, if you need help with dimensional analysis, meaning canceling out units, there are plenty of YouTube videos on that. Hopefully I'll be making up one too. And then make sure that you are able to cancel out units and do sig figs as well. Alright? Take care, guys. Have a good day.